Okay, guys, so now we're going to be looking at 3 by 3 by elimination. So we've done 3 by 3 systems with solution. Now we're going to be doing it with elimination. So we've already done this with 2 by 2. So this is going to be completing our last little bit of elimination substitution. So we have our basic steps, and then I've got my other ones for you just like we've done in the past. So first thing is we want to make sure our equations are lined up. X, Y, Z equals C. So C is always going to be a constant number. So that's super important that it's lined up. Make sure all variables are present. If not, you have to plug in a 0 for any of the missing terms, like we did for synthetic or long division. Then we're going to pair the first two equations and pair the last two equations. So what that means, so then we're going to eliminate, our basic one that we're talking about. We're going to eliminate the same variables in both pairs from step 1. Then we're going to write a new equation as a system of two variables. Once we've done that, we're going to solve for two missing variables. Then we're going to plug in both solutions from step 4 into one of the original equations and solve for the third variable. So we're going to write our answer as an ordered triple. So those are our basic steps. There's 7. This is going to be the same thing, just differently worded so that y'all can make sure you understand what's going on. So steps to solving a 3 by 3 systems of linear expression by elimination. It's also sometimes called combination. So we're going to select a variable to eliminate. So we can either choose X, Y, Z. It doesn't matter. Tip, select a variable that can be eliminated with the fewest modifications to the original equation. So that means we're not trying to manipulate it a ton. Second step, we're going to combine any two equations, which means multiplying by a constant to eliminate the selected variable. Third, we're going to combine a second set of equations, which may be multiplied by a constant to eliminate the same variable. After that, we're going to solve the new 2 by 2 system. Then we're going to substitute the values found in step 4 into any of the original equations to solve for the remaining variable. And then we're going to write that solution as an ordered triple, as I've said before, if it's appropriate. When it says if it's appropriate, that's going to mean if it's going to be no solution or infinitely many solutions, which are possible in these scenarios. So now, guys, I've talked you through the steps, but now I'm actually going to write it with you like we have done before. So first thing, we're going to select a variable to be eliminated. So if y'all can see on the side here, I've got my 1, 2, 3, so I can designate which equation I'm messing with. So I think it's going to be easiest to eliminate the y just because it already is the smallest, doesn't have constants in front of it, and it's pretty basic. So I'm going to have my y will be eliminated. Okay, so from there, I'm going to put together equation 1 and equation 2. And I'm going to be doing the elimination for it. So my equation 1 is x plus y plus z equals 0. And equation 2 is 2x minus y plus z equals 0. So if y'all notice on that, guys, I can instantly do elimination because my y's are already opposite. So that means I'm going to end up with 3x, cancel out, plus 2z equals 0. I'm sorry. This needs to be a 25. So then it'll be 25. So I have a new 2 by 2 equation, which is going to be 3x plus 2z equals 25. So this is now going to be number 1. So now I'm going to combine a second set of equations. So I am going to be doing that right here. And I'm going to do equation 1 and equation 3. The reason for that, guys, is they're still opposite, so it makes it an easy transition. So that's going to be x plus y plus z equals 0. And then x minus y plus z equals 8. So I'm going to do the same thing. I'm going to add them so I can eliminate. So that's going to give me 2x, cancel my y's, plus 2z equals 8. So guys, I am going to simplify this because it can be done. I can divide 2 all the way across, and I can get x plus z equals 4, just to make my life easier later. And then that's going to be my second equation now. So that's how we do the first 2 steps. I'm going to scroll down. I'm going to solve the new 2 by 2 system for both of its variables. So my new system is going to be 3x plus 2z equals 25. And then I've got x plus z equals 4. So we're going to eliminate z. That's what we're going to focus on right now is our z. So I'm going to multiply this bottom equation by -2. So I'm going to end up with -2x minus 2z equals -8. And then I have my 3x plus 2z equals 25. So now I'm going to do the elimination. I'm going to add. So those two are going to cancel in the middle, and I'm going to end up with x equals 17. And that's one variable. Now, I can plug in that x into my equation, my second equation over here, which was x plus z equals 4, to find z. So I can plug 17 in right here and get 17 plus z equals 4, minus 17 on both sides, and I get z equals -13. So now I have 2 of my variables. I can now substitute those 2 variables in for one of my original equations. Well, my easiest original equation was x plus y plus z equals 0. So I can literally plug in 17 plus y minus 13 equals 0 and solve for it. So 17 minus 13 is going to give me 4. So that's going to be y plus 4 equals 0. If I minus 4 to both sides, then I get y equals -4. And now I can do an ordered triple. So my ordered triple is going to be x, y, z. You always put it in alphabetical order. So then I'm going to end up with 17, -4, -13 as my answer. So that seems like a lot of work, and I totally understand. But we got to go through each different step to make sure we get through all of it. So here's going to be our first example. I'm going to number my equations 1 through 3. 1, 2, and 3. And now I'm going to take my first 2, and we're going to do elimination and give me a new 2 by 2. So I've got 2x plus y minus z equals 5. And then I have 3x minus y plus 2z equals -1. So this is my first equation and my second equation. Well, this one's pretty easy, guys, because my y is going to be my variable that I'm eliminating, because it's super easy on this. So I'm going to eliminate here, and I'm going to end up with 5x minus z equals 4. So now this becomes my fourth equation, just so we have it separated. And because I chose to do the y on this one, I'm going to do y on my next one, and I'm going to do my second and third equation. So my second equation is 3x minus y plus 2z equals -1. And then I've got x minus y minus z equals 0. But on this one, I have to change my signs so that my y's can be opposites. So I'm going to multiply this entire thing by a -1. And I'm going to get -x plus y plus z, and that's nothing else is going to change. So then I can add them together. So I'm going to end up with 2x, cancel my y's, plus 3z equals -1. And this is going to be my fifth equation. So now I've got to take these 2 new equations and use elimination for them. So I'm going to have my fourth and my fifth equation. So I'm going to have 5x minus z equals 4. And then I'm going to have 2x plus 3z equals negative 1. Well, I still have to find a way for these to match. And I've decided I want to make the z my eliminating one. So I've got to multiply this first equation by 3. So I'm going to put it down here in black. And that's going to be 15x minus 3z equals 12. And so now I'm going to do my elimination. So these will cancel right here. And I'll end up with so we have negative 3 that we're going to multiply by. So I'm going to have negative 15 and then negative 3z and negative 12. So doing that, I'm going to end up with negative 13x equals negative 13. Divide by negative 13 on both sides and get x equals 1. Okay, so now I'm going to plug this 1 back in for one of my equations so I can find z. So I'm going to do my 2 times 1 plus 3z equals negative 1. So then I have 2 plus 3z equals negative 1. That's going to give me 3z equals negative 3 divided by 3. And I get z equals negative 1. So now I can take both of these and plug back into one of my original equations. So I'm going to take that third equation, which means I'm going to have 1 minus y minus negative 1 equals 0. So that's going to change to positive ones, which means I'm going to have negative y equals negative 2, which means I'm going to have y equals 2. So that means my final answer should end up being 1, 2, negative 1. Okay, so now we're going to move on to our next example. So first thing, we're going to number our different equations again. So we've got 1, 2, and 3. So we're going to combine these two, our 1 and our 2, and we're going to have 2x plus y minus z equals 5, and x plus 4y plus 2z equals 16. So to do that, I'm actually going to change this top one by multiplying by 2 and focus on changing and taking away my z's. So I'm going to end up with 4x plus 2y minus 2z equals 10. And I'm going to add those together. So I'm going to end up with 5x plus 6y, cancel my z's, equals 26. And that's going to be my fourth equation. Then I'm going to combine my second and third equation. So my second equation and my third equation. So my second equation is x plus 4y plus 2z equals 16. Then I have 15x plus 6y minus 2z equals 12. Well, if y'all notice, my z's are already opposites for me, so I can go straight into my adding to cancel. So then I'm going to have 16x plus 10y cancel equals 28. So this is my fifth equation. So now I'm going to take my fifth and my fourth equation, and I'm going to try to get those to work out. So here's my fifth equation, and I've got 16x plus 10y equals 28. Well, these ones aren't the most easy to work with. So I've got to figure out a way to get two of these things to equal something. Well, I know that 6 and 10 can both get to 30, but they have to be done two different ways. So this first one, I'd have to multiply by 5, while the second one, I'd have to multiply by 3. So we're going to do that. And that's going to give me 25x plus 30y equals 130. And then I'm going to do this other one by a negative 3 and end up with negative 48x minus 30y minus equals negative 84. And then we're going to add these together. So I end up with negative 23 x, cancel my y's, equals 46. Divide by negative 23 on both sides. And I get x equals negative 2. So now I can plug in that negative 2 into one of the equations that we just found to make our next one. So I am going to do the 2x. I'm going to do the 5 times negative 2 plus 6y equals 26. So I end up with negative 10. I'm going to add that to my 26, and I get 6y equals 36, divided by 6 on both sides, and y is going to be 6. So now I can put my x and my y into one of my original equations. So that's going to be over here. I can do my 2 times negative 2 plus 6 minus y equals 5. It's going to be negative 4 plus 6 minus z equals 5. So I'm going to end up getting z equals negative 3, which means my final answer is going to be negative 2, 6, negative 3. So this next one, this is probably going to be the first time one of our answers is going to be a fraction / decimal. So we're going to do the exact same thing. We're going to label 1, 2, and 3. So we're going to make 1 equal. But first, I want it to be in the correct order. So remember, we said it needed to be x plus y plus z equals constant. So this just needs to be forced into that way. So QRS, so it's going to be Q plus R plus S equals our constant. So I'm going to end up making this first one 6Q minus R plus 2S equals 8. And then my second one, I'm going to end up making it 4Q plus 2R plus 5S equals 1. So to go from there, I've got to figure out how I'm going to get this to go away. So this first one, I can actually multiply by 2, and I can get my next one. So I'm going to move it down into black over here, and I end up with 12Q minus 2R plus 4S equals 16. And then I can add these together. So that's going to give me 16Q, cancel my R's, plus 9S equals 17. And that's my fourth equation. So then I'm going to do my second and third. And I have 4Q plus 2R plus 5CS equals 1. And then I've got to do the same thing with my 3. And I'm going to change the order to be 2Q plus 3R minus S equals negative 9. So now I'm going to add those. But again, I've got to change up the order to make it match. So I want to deal with my 6. I feel like my R's, I can make them both 6s. So I'm going to multiply this one by 3, and I multiply this one by negative 2. So I end up getting 12Q plus 6R plus 15S equals 3. Then I get negative 4Q minus 6R plus 2S equals 18. And then I add. So when I do that, I'm going to end up with 8Q, cancel the R's, plus 17S equals 21. So this is 5. So now I'm going to create these equations. So I've got 8Q plus 17S equals 21. Well, I can multiply this one by negative 2 and get them opposite. So that means my new equations are going to be 16Q plus 9S equals 17, negative 16Q minus 34S equals negative 42. And then we're going to add. So our Q's will cancel. I'll end up with negative 25S equals negative 25. Divide by negative 25 on both sides, and I get S equals 1. So now I can plug that S into one of my equations. So 4 can be 16Q plus 9 times 1 equals 17, which will leave me with 16q equals 8, which divided by 16 is going to get me q equals 1/2 or 0.5. And then my last one is I'm going to plug both of those in. So I'm going to plug it in for my 3r equation. 3r times s, which is 1, minus 2 times 1/2 minus 9, which means I'm going to end up being 3r equals negative 9, and that means r equals negative 3. So my final answer should be negative 1/2 for my q, negative 3, 1. Okay, now we're going to move on to the next equation. So our next equation, we're going to do the same thing and number them. We've got 1, 2, and 3. So as y'all can see, these ones are already put in there, but where issue is we actually have to have 0 terms because we have to have an x, y, z. So this first one is going to be x minus 3y plus 0z equals 0. Then I'm going to have x minus 2y plus z, 0x equals 0. So now I have my equations written correctly. So I'm going to start with 1, 2x plus 2y plus z equals 72. And then I'm going to take my second equation, and it's going to be x minus 3y plus 0z equals 0. So now I've got to figure out what I want to cancel. Well, I'm going to cancel the y's because 1's already negative. So I just have to multiply this equation by 3 and this equation by 2. So that's going to give me 6x plus 6y plus 3z equals 216. And then I'm going to have 2x minus 6y plus 0x equals 0. Which means I'm going to end up with 8x, cancel my 6's, plus 3z equals 216 as my fourth equation. Fifth one is I'm going to do my second and my third equation. And I'm going to have 2 I'm going to have x minus 3y plus 0z equals 0. And then I have 0x minus 2y plus z equals 0. So I'm going to do the same thing, and I'm going to deal with my y's. So I'm going to multiply this by 2 and this by 3. And I'm going to have 2x minus 6y plus 0z equals 0. And then I'm going to have 0x plus 6y minus 3z equals 0. I'm going to add those together. I get 2y, the 6's will cancel, minus 3z equals 0. That's going to be my fifth equation. So then I'm going to move it over here. 2x minus 3z equals 0. Those are already there, so I can cancel immediately. And I'm going to get 10x equals 216, which means my x is 2.16. I can plug that into one of my last equations, which I can do 2.16 equals 3 by y, divide by 3, and I get y equals 7.2. Then I can plug in my last one, which is going to be for my z, and I have 2 times 7.2, which means my z will be 14.4. So my answer is going to end up being 21.6. 7.2 and 14.4. Okay, we're going to move on to E. So again, we've got to maneuver this one. So I need it to be 2x plus y plus 0z equals 10. That's the first equation, my second equation, and my third equation. So I'm going to take my second equation, which is going to be 2x plus y plus 0z equals 10. And my second equation, which is going to be negative x plus y minus 2z equals negative 2. Well, my x's are almost perfect, so I'm just going to multiply by 2. So that means I'm going to have 2x plus y plus 0z equals 10 minus 2x plus 2y minus 4z equals negative 4. I'm going to add those together. My x's will cancel. I'll get 3y equals negative 4z equals 6. And that's my fourth equation. So then I'm going to do my second and my third equation. So I'm going to have negative x plus y minus 2z equals negative 2. Then I have negative, once I rearrange this is actually going to be 3x minus 2y plus 4z equals 7. So now I've got to figure out what's the best one to work with. So I'm going to multiply my first equation by 2 so then my y's will cancel. So I'm going to just move it down here and get negative 2x plus 2y minus 4z equals negative 4. Then I'm going to add those together. So I'm going to end up with x, cancel equals 3. So then I got an instant one there. So now I can plug back into one of my equations. So I'm going to plug back into the first equation, and I'm going to have y equals negative 2 times 3 plus 10, and end up getting y equals negative 6 plus 10. Then y equals 4. Then I'm going to plug my 3 and my 4 in to one of my equations, and I'm going to have negative 3 plus 4 minus 2z equals negative 2. And I'm going to end up being 1 minus 2z equals negative 2. And then it's going to be negative 2z equals negative 3. Divide by negative on both sides, and I get negative z. I get z equals 3/2 or 1.5. So it means my answer should be 3, 4, 1.5, or it can be 3, 4, 3/2. Both are perfect answers in what we need. Okay, so now we're going to go to F. Same thing, so it's going to be first equation, second equation, third equation. So I am going to kind of go through this one a little fast since most of y'all have this set up already. So it's going to be that 4x, 2y plus 5z, and then I have my 4, so it's 4x minus 2y plus 5z equals 6, and then I've got 3x plus 3y plus 8z equals 4. I want to cancel my x's, so this one's going to be times 3, this one's going to be times negative 4, and I'll end up with 12x minus 6y plus 15z equals 18, and then I'll have negative 12x minus 12y minus 32z equals negative 16. Gonna add, and those will cancel here. I'll end up with negative 18y minus 17z equals 2. Then on my other side, I'll have 3x plus 3y plus 8z equals 4. And then I have x minus 5y minus 3z equals 5. I'll multiply this whole thing by negative 3. Then I'm going to have negative 3 plus 3y plus 8z equals 4 minus 3x plus 15y plus 9z equals negative 15, which will mean I have 18y plus 17z equals negative 11, which cannot be true. Because if we're saying that, if we're going to plug this in and have 18y plus 17z equals negative 11, that's going to cancel, that's going to cancel. So if 0 equals negative 9 is not true. So our answer is going to be no solution. Okay, so now we're going to move on to G. So G, we have 1, 2, and 3. We'll have to reorder these. So it's going to be x plus 0y plus 6z equals 12. Then I'm going to have negative 2x plus 3y plus 0z equals 6. And then we're going to have 0x right here plus y minus z over 2 equals 5/2. Okay, so we're going to do the first equation and the second equation. So x plus 0y plus 6z equals 12. And then we'll have negative 2x plus 3y plus 0z equals 6. We'll multiply this first equation by 2. And we'll move it down in red. So I'll have 2x plus 0y plus 12z equals 24. We're going to add those. Those will cancel. I'll end up with 3y plus 12z equals 30. Perfect. So that's my fourth equation. So now we're going to do the third one. But before we're going to do anything, that third equation, we're going to actually get rid of those fractions. So it's going to be 0x plus y minus z over 2 equals 5 over 2. Whole thing's going to be divided by the common multiple. So I'm going to have 0x plus 2y minus z equals 5. Then I can take this one and I can deal with it on the next rotation. So that means my third equation is going to be dealing with my second equation. So we don't have to do anything else. We don't have to actually multiply. We don't have to do anything else because it's already, once we move it in there, is actually in the form 0x plus 2y minus z equals 5. So it already doesn't have an x, so we can plug it straight in over here as our 2y minus z equals 5, and we can multiply it by 12 to get this correct. So we'll end up with 3y plus 12z equals 30 times, so it's going to be 24y minus 12z equals 60. So we're going to add those together. They cancel. We're going to end up with 27y divided by 27 equals 90. And our y is going to be 10/3. So then we're going to plug that in. So I have 2 times 10/3 minus z equals 5. And that's going to end up with me getting z equals 5/3. Then I'm going to plug them both in with x equals 6 times 5/3 equals 12. And that's going to end up with x equals 2. So my equation will be 2 10/3 5/3. Okay, so now we're going to move on to our last two before we do word problems. So we have, our last one before word problems. This is a long one. So we have one equation, 2 and 3. I'm going to reorder the second one, 2x plus 0y minus z equals -2. And then same thing over here, but I'm going to multiply by 12 because that's my common denominator, and I'm going to end up with 3y minus 2z equals 0, which is ending up being 0x plus 3y minus 2z equals 0. Okay, so I'm going to have my first equation, which is going to be 6x plus y minus 4z equals -8. And then I'm going to multiply my second equation by 4, and that means I'm going to end up with 8x plus 0y plus 4z equals 8. That's going to make it where my z's cancel, so then I end up with -2x plus y, cancel here, equals 0. Okay, and then I'm going to do my second and third equation, and that's going to be -4x plus 0y plus 2z equals 4. 0x plus 3y minus 2z equals 0. Those are already there, so I can just add. -4x plus 3y equals 4. This is my fifth equation. This is my fourth. I'm going to move my fifth over. negative 4x plus 3y equals 0. I'm going to multiply my top equation by 3, negative 3, so I get 6x plus negative 3y equals 0. Add those together. I'm going to cancel my y's, and I'm going to end up with 2x equals 4, which means my x equals 2. Plug in my x for one of my fourth equation, which is going to be negative 2 times 2 plus y equals 0. So y equals 0. And then I'm going to have my y equals 4. And then I'm going to have my next one, which is my last one. 3 times 4 plus minus 2z equals 0. 12 minus 2z equals 0. And then z will equal 6. So this equation will end up being 2, 4, 6. Nice and easy. Okay, for the word problems, I'm going to help you set them up, but I'm not going to give you how to solve them. So the setup is going to be A plus B plus C equals 49,000. And then 25A plus 20B plus 15C equals 105. And then A equals B plus C. That's the first one. Next setup is going to be 1M plus 1N plus 10 with a smiley face to make sure you know it's and then 375. Then it's 2M plus 2N plus 10 equals 640. Then 1M plus 3/4 of an N plus half of an O equals 209. Our next one is 3C plus 2D plus 6E equals 7.20. 4C plus 4D plus 1E equals 7.80. 2C plus 2D plus 10E equals 7.00. And our last one is going to be 10 plus D plus Q equals 16.05. N plus 0.1 D plus 0.25 Q equals 2.15. And then N equals Q plus D minus 8. So guys, that's a lot of stuff. This is the quick version on your notes with doing the